15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you, as always, for joining us on this, the Space Nuts podcast, episode 206. It's all about astronomy. My name is Andrew Dunkley, your host, and with me, as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. We do a bit of space science as well as astronomy, so
Indeed,
we cover all
we
that.
do. And yes, now I'm just back from my Not Canada tour.
Oh,
I'm
good.
supposed to be in Canada and Alaska at the moment, but I don't know why, but we had to cancel.
No,
So,
yeah, something's going on.
yeah. So we did a Not Canada tour and just did a little, now that they've opened up the roads in our state and we can travel a bit, we visited some family and friends. So we did a trip to Maitland, then down to Sydney to see the boys, and then cut back through the mountains and visited friends in Orange and Bathurst before heading home. So instead of 19 days in Canada or Alaska, we did 3 days in New South Wales, or part thereof. And we called it the Not Canada tour.
Very good. Well, that's all right.
It was nice, though.
Yeah, and it was probably a lot less uncomfortable here and there as well, like the sitting on the flight and everything. Yeah.
Oh, yeah, that. But I tell you what was uncomfortable was we were in Sydney around the time of those protests.
Yeah.
I won't get into the politics of that. But social distancing seems to have just gone out the window. And I found that a little concerning.
Yeah.
So it was not a good feeling around Sydney on the weekend, I must say.
Well, in my bit of Sydney, it's really good. Everybody stays apart. But yes, you're right in the centre, and especially with a busy weekend like that, very much so. Anyway.
Yes, indeed. Anyway, let's get down to business. We've got a lot to talk about, including one of my favourite subjects, the space doogie.
Yep.
Yes, it's back in the news, Oumuamua. But the reason it's in the news, to steal one of Fred's crutch lines, is that they have a new theory as to what it is coming out of the University of Chicago, I believe. We'll also be looking at an Earth-like planet orbiting a sun-like star. You know, Fred, there's a new book out that's got a similar storyline attached to it. I can't remember the name of the thing. And we've got a couple of questions. Have we ever been visited by aliens? I mean, that's a pretty straight down the line yes or no answer, I think, but I'm sure we'll be able to put more into it than that. And concerns about Starlink, the Starlink satellites, which we have talked about before, but it's an ongoing issue. In fact, I read another story about it during the week, which raised a few questions as well. So, Fred, let's get down to business. A new theory about our exo-asteroid Oumuamua, affectionately known in the astronomical world as the space doogie.
Andrew,
At least by one person who's not an astronomer.
There's one person calls it that. Now, I wonder who that could be.
I have no idea.
I still go with the French breadstick analogy, which seems much more wholesome somehow. But of course, both of us are wrong. The famous Oumuamua, the first messenger from afar, discovered back in 1917. Hard to believe it's, excuse me, getting on for 3 years ago. It was October. I'm sorry, forgive my froggy throat. October the 19th, 2017. That Oumuamua was picked up and instantly recognized by astronomers as having come from outside the solar system because of its hyperbolic orbit, but also highly studied, in particular its light curve that demonstrated that this was an object that was not circular, that was, kind of basically spinning end over end as it moved through the solar system, and the light that we saw from it varied as the sunlight reflected from it increased and decreased because of the shape of it. So this elongated shape. And the thing that you and I have talked about many times before, that really set the cat among the pigeons as far as it being an alien spacecraft was concerned, was the fact that it was experiencing what we in the trade called non-gravitational perturbations, which is a fancy way of saying something was pushing it off its orbit. and the expected cause for that, which would be outgassing, basically, which is what comets do. As the ices melt as they get near the sun, or the ices sublime as they get near the sun, that outgassing will change the orbit of something. So everybody looked very closely for signs of either dust or gas coming off this thing, and none were found. It was simply a spot of light. So that led to the idea of alien spacecraft. And of course, the world's radio telescopes beamed in on it and nothing was heard. So it's probably only two people in the world who think it's an alien spacecraft. You might be one of them. I'm not the other. So theories have abounded. And in fact, you and I think, have talked about most of them. I think, Andrew, you and I have spoken more about Oumuamua than anything else. And it's just so that you can get that line in at the beginning.
Absolutely true. Although I think black holes probably are the number one topic on Space Nuts.
That's right. Yes. Okay. All right. Let's put it this way. Any other object in the solar system, even though it's heading out of the solar system because it's not a permanent member. So the theories for what it was or what it is basically usually involved an asteroid from another solar system, maybe one that has undergone a collision and hence it's been flung out of the solar system. There was a story I think we covered a few weeks ago which suggested that maybe what we were seeing here was the result of a collision of two planetesimals. These are the building blocks of planets in another solar system, because there's some evidence that the debris of that might be shard-like, might be this sort of shape. And so I think we confidently came to the conclusion that's probably what it was. But now there's another conclusion for us to come to. And I like this one very much because it gets...
Okay.
Right. Sorry, go ahead.
No, I'm just interested to know what it is.
Okay, sorry. It gets right to to a fundamental level in astronomical, maybe the science of the way solar systems evolve. It goes right back to the beginning, because we know that star formation regions are often associated with what we call giant molecular clouds. These are giant clouds of molecular hydrogen. So hydrogen atoms join together to make H2, the hydrogen molecule, the most common molecule in the universe. It's everywhere. And these giant molecular clouds are very significant items within our galaxy. As I said, they're associated with star formation. So what has been proposed is that this object, Oumuamua, actually comes from one of those. And indeed, the idea is that you've got molecular hydrogen, perhaps in the core of one of these giant molecular clouds, which is so cold that the hydrogen has solidified. And so you've got, as the lead author on this paper said, he described it as a frozen iceberg of molecular hydrogen. That's Darryl Seligman, who's actually, I think he might be at Yale, but he's on his way to the University of Chicago. He says, this explains every mysterious property about it. And if it's true, it's likely that the galaxy is full of similar objects. So what it explains...
Okay.
Go on.
So in terms of a normal asteroid, which is sort of dust and ice, this is a completely different animal.
Totally different. Nothing to do with planets or collisions of planets, but basically something that is spilled out of a giant molecular cloud, maybe by a collision between two of these things. The key thing that this theory offers to our understanding is that if it's outgassing molecular hydrogen as it passes near the sun, basically that's not going to show any visible sign. And in particular, there's no dust particles involved. There's actually no dust in this thing, unlike a comet, which is basically a ball of ice with dust bound into it. This thing is just hydrogen. So what they have done is, looked at the detail, the physics of how this might behave. There's no light, there's nothing to burn, doesn't reflect light, so you can't detect it. And you only get this stuff, molecular hydrogen ice, forming really almost at absolute zero. It's just a little bit above absolute zero. So these things are perhaps being formed in the cores of giant, the cores, that's CORES, of giant molecular clouds. These places where stars are born. So it is an astonishing idea, but it fits all the bills. It fits the idea of the acceleration. Fits the fact that we couldn't see anything outgassing. There's a nice explanation for the shape of it as well. Because I
don't think it'll beat my theory, but let's go for it.
Author Darrell Seligman, he puts it beautifully. So what you've got is, this thing's being irradiated as it passes through the solar system, and maybe it's gone through many solar systems. We don't know, or at least passed nearby to stars. So it's being irradiated with both the particles and the radiation, the electromagnetic radiation from these stars. And what that does is just sort of, as he puts it, whittles away the surface. And so this is what he describes. He says, imagine what happens to a bar of soap. It starts out as a fairly regular rectangle, but you use it up and it gets smaller and thinner over time. So he says, Oumuamua has basically, been wandering through space. This thing got smacked like a bug on a windshield, he says. And what he's suggesting is that as it, encounters the solar system, the radiation from the sun actually helps to increase this slimming down process that gives you this very odd shape. Really neat theory. Problem is, that's as far as it goes. We can't really say any more because this thing's gone. However, we should be looking out for more. And a few commentators have mentioned that the observatory or the telescope that will really bring these things home in terms of our discovery of them is the Vera C. Rubin Observatory, formerly the Large Synoptic Survey Telescope, scheduled to be online in a couple of years' time, hopefully. And that will, I think, net many interstellar objects, whether they're asteroids or icebergs from giant molecular clouds. Maybe we'll find out then.
Yeah, and you did say something that I was going to ask you about, but I want to go back to it. And that was, you said that these things come from the same clouds that form stars. Now, correct me if I'm wrong, but those clouds collapse under their own gravity, and that creates stars, which is superheat. And yet these are at the opposite of the scale, yeah. So it just seems sort of counterproductive. No,
it's a great point. So I guess what you're talking about is where it depends on the density, on the amount of compression that there's been. So where the stars are forming, you've got really high densities of hydrogen and helium. That collapse under gravitation is what basically switches on star formation. But these molecular clouds are vast places. And when you think of things like the picture of the pillars of creation, the star formation in there is only happening right at the tips of those pillars of creation. There's an enormous amount of stuff around them, and these molecular clouds almost certainly have areas that are very, very cold indeed, and that's what they're suggesting. So I think you can have both.
So these clouds produce both.
Yes, that's right.
Who knows what else they might be producing?
Exactly. What else is in there? But I do like the idea of hydrogen icebergs. That's one I've not heard of before, and I think is relatively new to the scientific community, at least the ones who are not concentrating on giant molecular clouds.
Very disappointed to learn that it's probably not remnants of the dog star. But anyway, that's the way it goes. But there was another one more recently, so they're probably thinking the same thing about that one.
That one is a comet, though. The other one's got all the signs of a comet, yeah. And actually very similar components to what comets in our own solar system have. So
essentially there is still officially only one space doogie.
There is indeed, that's right. Only one space breadstick as well.
All right. But yeah, as you say, we'll be in a position soon to maybe find many, many more, and it stands to reason that there are probably billions of them, given the size of the universe and how much junk is floating around out there, indeed. You're listening to the Space Nuts podcast. Andrew Dunkley here with Fred Watson.
Roger, your lots are here also.
Space Nuts.
Now, Fred, I have got some exciting news. I know there's been a lot of exciting news with the Space Nuts podcast in recent times, but we have a new URL.
Wow.
Instead of trying to spell out bytes.com/spacenuts to everybody, we can simply tell people to go to spacenutspodcast.com. There you are, spacenutspodcast.com. It's our brand new website URL. We're sort of still in the design phase, but it is operational, so you can go on there and have a look at all our episodes. They're all listed. You can visit the shop. You can see what's happening with some of the things that are going on in the astronomical world that we have reported or have passed on through social media. And so much more. So check it out. spacenutspodcast.com is our new URL, and we'll be building on that as time goes on. And as the well thought out and descriptive catchphrase we use to describe ourselves, our slogan, astronomy, space, science, and stuff is what it's all about. Now, Fred, this is another exciting story. Sorry?
I've just had a look. It looks great.
It does. It's come up really well. That logo, people talk about that logo so much. It's my brother in his prime as a graphic artist.
Mm-hmm. Absolutely.
Now, let's talk about this next story, which I find fascinating in that they seem to have found an Earth-like planet orbiting a sun-like star. And that's prompted a few questions in my mind already. But what have we found here?
Exactly what you said. Yeah, this is a sort of fairly well-known planetary system, extrasolar planetary system called Kepler 160, discovered by the Kepler spacecraft. For, I think, 6 years or so, it's been known that Kepler 160 has two orbiting planets, which are Kepler 160b and Kepler 160c. That's the normal nomenclature, which are actually much closer to Kepler 160 than the Earth is, and they're bigger planets, and they would be very hot. Really, not any kind of place where we might think, well, here's an analog of Earth. But another one's now been found that looks very promising as a pretty good analog of our own planet. So the first thing to know is that unlike most of the stars which we know have planets around them, Kepler 160 is a sun-like star. It's the same class, probably very, very similar surface temperature to the sun, maybe just a smidgen more. But it's not a red dwarf star, which is what most of the planetary hosts that have been found so far are. And the reason for that is it's easier to find a planet going around a red dwarf star because the star's small, and as the planet crosses in front of it, it produces a bigger dip in the light output of the star. Red dwarf stars are slightly peculiar, though, because even though they're cooler and smaller than the sun, they've got much more active surfaces. So lots of tangled magnetic fields, solar flares that make ours look fairly tame from the sun. And people have, astrobiologists have worried that this might rule out the idea of any life forms evolving on the planets of red dwarf stars. So that's why the idea of an Earth-like-ish planet, and I say that because it's thought to be almost twice as big as the Earth, about 1.9 times bigger than the Earth, but it's orbiting a sun-like star, and the critical thing, as you kind of hinted already, it's orbiting in the Goldilocks zone of the star, the habitable zone. In fact, its year is not very different from ours. Its year is 378 of our days. So that is, that makes it really interesting. It's likely to have a similar surface temperature to our own planet. In fact, I think I saw one suggestion that on average, it may well be about an average temperature of 5 degrees Celsius, which is actually lower than ours. We sit with an average surface temperature of 15 degrees. But 5 degrees, we're still above freezing, and, is interesting from an astrobiology point of view.
Yes, indeed. Yeah, I imagine the gravity would be a fair bit different. Would that be the case?
Right. It would be probably be higher. A lot depends. The key thing really about whether this is a place that might host life is what the atmosphere is like, and at the moment, the observations that lead to the idea that this planet exists. That they're not certain. They put them at the 85% level of probability that this is a real planet. And the reason I say that is that its effect on its parent star, as I mentioned earlier, because it's a sun-like star that it's crossing in front of. The dip in the star's brightness as this planet passes in front of it is very, very small, and so it's still, they're still teasing the signal out of the noise. And the other thing, of course, is that with a period of 378 days, that's how long you've got to wait between transits of the planet in front of its star. So it's quite a slow job. It's a matter of some years that will be needed before this will be confirmed at the 99% level, which is what you need to give it a tick as a confirmed planet. So
they're very, very sure it's a rocky planet, though, by the sound of it.
Yes.
No?
Yes. No, I think you're right. I think that's correct, that it's very likely to be a rocky planet. A super Earth is what these things are classified as. Interesting stuff, though. And once again, as in so many of our stories, Andrew, it's a question of watching this space because as more observations are gained, then we'll know more about it. But very interesting.
Is it close enough to, say, do some sort of spectrum analysis of its atmosphere and see what's going on there?
It is with the next generation of telescopes. It's actually quite a long way away. If I remember rightly, it's about 3,000 light years away, which is not nearby. But particularly with the Kepler Space Telescope, that will have the capability to do infrared spectroscopy on this object, and maybe we will discover more about it once that spacecraft is in orbit. And then, of course, further down the track, when we've got the 3 extremely large telescopes which are currently on the stocks, they too will contribute to this kind of science. So we'll certainly find out more about it, but maybe not within the next few months. I think it'll be down the track.
Yeah, but it's in the right place, and everything adds up. And look, let's face it, there have to be Earth-like planets orbiting sun-like stars out there. Probably squillions of them, but they're few and far between as far as our observations are concerned, and that's what makes it difficult. And I guess for a lot of people frustrating, because we want to find them. We want to find planets in habitable zones, because that just sort of opens the door a bit more to the possibility that there could be some form of life out beyond our solar system. And, analysing the atmosphere could provide telltale signs. Could.
Yeah, exactly. That's what that's what we're all looking forward to.
Now, I've thought of another reason why we wouldn't want to live on this planet, even if it could harbour life, aside from its gravity, which I think might be a bit stifling.
Yeah.
At a rotational year of 378 days, I think you said, you get ripped off if you. Let's just ballpark the figure of the average age of a human being at 80. On that planet, you'd only live 76.8 years. So. There's another reason not to go.
Yeah, that's a bit close to the bone for me. That
it's the same amount of time. Fred.
Yeah, I know.
It just doesn't sound that way. Yeah,
no, it doesn't.
It's like putting the car on cruise control. You feel like you're going slowly, but you really are doing the same speed.
Yeah, exactly.
All right. Hopefully there'll be more to tell on this particular planet, which sounds very exciting indeed. You're listening to Space Nuts. Andrew Dunkley here with the great Fred Watson.
3, 2, 1.
Space Nuts.
Now, I've mentioned many times that if you would like to become a patron, you can do that through patreon.com/spacenuts. You can also do it through Supercast. But now our distributor Acast is offering a similar option, which you can find out on our website, the new URL I mentioned earlier, spacenutspodcast.com. So if you're interested in contributing to the program for a few dollars a month, you can check out any of those options. And we do like to sincerely say thank you to our patrons for supporting the Space Nuts podcast, whether it's through Patreon, Supercast or Acast. They're all options for you. And as I've said many times, not mandatory, but you can contribute to the Space Nuts podcast for as little as $3 a month. And whatever you decide to do, we are eternally grateful. Thank you very, very much for supporting us. Now, Fred, we have some questions to answer, and we appreciate those as well. This one comes from Mike on the Isle of Wight. Hello, Mike. I've only recently discovered your podcast, and he's still listening. It's just amazing. And I think it's great. A sensible mix of humour and fact. A great listen. Isn't that nice? Now, my question is, why didn't the professional astronomy community react earlier to the protest about the likes of Starlink, when, as far as I understand it, the intentions were known back in 2015. It's all a bit late now to start decrying it. As an amateur astronomer or astrophotographer, I think, I'm used to having to dump a few images of a session due to satellites, but in the near future, I might find myself dumping more and more. And it's a depressing thought. All the best. Keep up the good work. He's brought a very interesting point up, one you and I have discussed before, in that these satellite launches are just filling the sky with thousands of satellites. And yes, are we going to face that problem? I know astronomers are certainly very much concerned about it.
We are, that's right. But Mike makes a really good point. Why didn't the professional astronomy community react earlier to protest about the likes of Starlink when, as I understand it, the intentions were known back in 2015? So I've basically looked for whatever message that was in 2015. And you're probably right, Mike. There was probably an announcement from SpaceX, because these things do tend to happen. But somehow that did not filter through to the astronomical community. So we were all taken by surprise when the first batch of 60 were launched late last year. Was that right? That's when it was, November, I think. It really has become a big issue in terms of light pollution, as you're experiencing yourself as an astrophotographer. So I guess rather than kind of rake over the ashes of whatever the history is, which I have tried to do but not been too successful with, really what we've got to be looking at is how we deal with this in the future. And the good news is that SpaceX are engaged with this problem. They realize that there is an issue here. They themselves have said that their satellites are brighter than they expected them to be. And they see the problem. They understand that astronomers are not happy about this and are essentially attempting to mitigate it. Still, the work is still in progress on that. So the latest news on that is that last week there was the 8th launch of 60 spacecraft, 60 satellites. That brings the total now to 482, I think it is, because 2 were launched initially before the first big dollop of 60. But one of the current batch of 60 satellites has been fitted with a sort of prototype sun shield. So it's a sort of visor that basically is aimed at reducing the light that's falling on the spacecraft, so you don't get this bright reflection. And as I've said, the mission last week included one of these Starlink spacecraft equipped with a visor to see what happens. So they will actually, if that works, it's SpaceX's Vice President of Satellite Government Relations, Patricia Cooper, who I think has figured quite largely in this discussion. She said that once they get the current design of spacecraft out of the way, and there are 80 more to come, then all the spacecraft will be fitted with these sunshades if they work. So they are working on it, and that's all good news. It's still not the ideal situation. There have been a number of times, and you and I think have spoken about this too, Andrew, a number of organisations, including the International Astronomical Union, the European Southern Observatory, have basically put out statements about this. They've done calculations that show exactly what the effect will be, and it's the wide-angle telescopes that are at the biggest, the wide-angle imaging telescopes that are at the biggest risk. The most prominent of those is one we've already mentioned in this episode of Space Nuts. That's the Vera C. Rubin Wide Field Telescope, which will come online in a couple of years. But the amateur world also uses wide field imaging telescopes, so it is going to be a problem for for astronomers like Mike, and we will just have to learn to live with it. I think it will be great if the sunshades actually do the job. Can I just add a little postscript to this story, Andrew, which is not really about the issue in hand, but I like the fact that, and this comes from a sustainability viewpoint, the recent launch, the launch last week of the latest batch of 60 Starlink satellites, was using a booster, a first stage, that had already flown 4 times. So it's had its 5th mission and landed successfully, and not on the barge which is called "Of Course I Still Love You." It landed on the barge called "Just Read the Instructions." These are the drone ships that Elon Musk's organization uses to capture them back. Yeah. And just I think we spoke about this a couple of weeks ago, but the rocket that was used to launch the Demo 2 into orbit, the Crew Dragon with Bob Behnken and Doug Hurley on board, that was a brand new one. It hadn't been used before, which is probably a good thing.
Yes, indeed. A couple of other things about this before we end the story. One of the other aspects of this that I suppose could be raised is space junk. And one of the interesting aspects of this is that they've already considered that, and apparently, according to their website, at the end of life, the satellites will use their onboard propulsion system to deorbit over the course of a few months. And in the unlikely event the propulsion system becomes inoperable, the satellites will burn up in Earth's atmosphere within 1 to 5 years, significantly less than the hundreds or thousands of years required at higher altitude. So they're designed to self-immolate and not become a problem in orbit. And these are in low Earth orbit, about 550 kilometres. So they are designed to sort of not stay up there and cause problems, which is a very, very good thing, just in case people were wondering. And of course, the reason they're doing all of this, Fred, as you and I have discussed, is to deliver high-speed broadband internet to locations where access has been unreliable, expensive, or completely unavailable. So there are good reasons behind it, but with the number of satellites they're putting up there, of course, there are issues and concerns, which is what has been raised in the question we got. So, Mike, hopefully that covers some of the issues. It might be one where you just have to grit your teeth and get on with it, by the sound of things. Now, Fred, sorry, you were saying?
Just with the mantra, Mike, you are not alone.
Yes, exactly.
Yeah.
Now, we've got a question, and thanks for the question, Mike. We've got a question now from Carey, who's in Port St. Lucia in Florida. Hi, Carey. Thanks for the question. He says, love the show. We receive new episodes on Thursday via iHeartRadio. So that's always a big day for me. Very good. As much as I enjoy Ancient Aliens on the History Channel, it seems highly improbable that laws of physics as we know them allow so great a distance to be travelled by space travellers, unless you're writing science fiction books where those questions are just open-ended, you don't have to answer them. Fred, do you think it's possible that we've been visited by aliens?
Well, yeah, it is possible. Not probable, but it's possible. The fact is, though, there is absolutely zero evidence for this having happened. Of course, the most famous pseudo-evidence for visitations was the Nazca Lines, which were studied in the 1930s and 40s and 50s. Books were written about these Nazca Lines in the Peruvian desert, which show enormous figures and lots of straight lines. I've seen them from the air and on the ground myself. They're very impressive, but it's nothing to do with aliens. There are all the marker pegs that were used by the people who actually made them in about, if I remember rightly, 400 or 500 AD, that sort of time ago. The wooden marker pegs are still there, and you can radiocarbon date them. That's how we know when they were laid down. There is really no evidence that we've been visited. But it's an appealing idea. And I have to say, that's the underlying theme of 2001: A Space Odyssey, which still remains one of my all-time favorite science fiction movies, that we were visited. I don't know. When I think about these things, the way I think current thinking in astrobiology is going suggests that we might be the aliens that one day might visit other worlds. That maybe, just maybe, we are in the lead in terms of the development of intelligent life, or at least in the region of the universe where, given a million years or so, you could get around a lot, i.e. within our galaxy. That it may well be that we're the only intelligent species in the galaxy. And that sort of, it does mean that if you're talking about visitations by higher species, then it might be us doing it a million years down the track. However, that's pure speculation. So the answer is yes, it is possible, but no, it's not likely at all. It's an extremely unlikely thing to have happened. If somebody can produce evidence, though, that would transform the whole thing, and we would really have to rewrite our history books in a big way.
Yes, I suppose so. And some would claim there is evidence that's been analysed and found. It's been portrayed in some of those so-called documentaries that appear on, 11 o'clock at night. But I suppose it's a question everybody wants to hope is probable. But you've got to be realistic about the time and the space that is required to be travelled. And we bring into effect the Drake equation again, which still quite clearly states there is only one planet in all of the universe that we can categorically say carries life. And until we can prove otherwise, there's very little to support the possibility, let alone the probability. I mean, microbial life aside, we in terms of intelligent life, we are it. And some would question that.
What a good note to end on.
Although I must say, we talk. You talked about those lines in Peru and that they were created by people. In modern day thinking, we always assume that ancient peoples weren't real bright. There's a difference between intelligence and knowledge, and I think that we assume that they are dumb because they were ancient. But I think the capacity to think and the capacity to problem solve improved knowledge over time, and here we are now with the benefits of those earlier peoples building knowledge and creating the capacity to solve problems. So back then, they solved a problem. They wanted to do something. How do we make giant figurines in the ground? They used mathematics.
Exactly right, Andrew, and I'm really glad you made that point, because one of the things when you talk to researchers in archaeology, and I had the great privilege back in 2007 of visiting Peru with Peru's leading archaeologist. But when you talk to them about the Nazca Lines, and they talk about the theories that what you're seeing is the result of alien visitation. What that does is it essentially undervalues the capabilities of these people in exactly the way you've described. They didn't have knowledge, but they had intelligence, they had understanding. They essentially did this. They probably drew the figures out on much smaller, either in the ground or on paper or wood or something, and then used effectively a pantograph, a gigantic pantograph, probably made with pegs and string, to recreate them as giant figures. And it was all about encouraging their shamans as they soared through the sky in their intercession with the gods. It was very much based on that kind of philosophy. Really, really interesting stuff. But nothing to do with aliens.
And one more thing I heard many years ago, I think it might have been in a documentary or an article or something, but if you could create a time machine, go back thousands of years and pluck a Stone Age baby out of the past and bring it to our time and bring it up as one of us, it would adapt.
Yeah,
it would be capable, as capable as anyone else, of living in this society. So it's all about knowledge. It's not lack of intelligence.
That's right.
And you just got to look at the young children of today and how they adapt to the technology that's been created in such a short period of time.
Yeah.
They have no issue at all. We are very adaptable and clever creatures, and we absorb knowledge like sponges. It's fascinating when you really look into it. It's just amazing what we've achieved and what we're capable of, and who knows where it's going. I mean, we're just on the cusp of the technological revolution, as far as I can tell. Who knows what the world will be like in 100 or even 1,000 years? It's just. It's exciting, but we won't be around to see it, Fred, unfortunately. But, well, we'll try, but at this stage, no. But, it makes for a good, morning tea discussion at the office, I reckon. We're going to have to wrap it up, Fred. Thank you so much.
Great pleasure, Andrew. Good to chat, and we've covered some great topics today, and look forward to doing the same thing next week. Take care, Andrew. Look after yourself.
You too. Thank you so much, Fred. Fred Watson, Astronomer-at-Large. And I do encourage you to jump online and record your questions. We love getting the audio questions as much as we enjoy getting the written ones, but we do love to hear your voices. So don't forget to hit the recorder when you visit our website and record your questions. spacenutspodcast.com is our new URL. While you're there, you can visit the Space Nuts shop. And I'd also encourage you to talk to each other through the Space Nuts podcast group on Facebook, or follow the Space Nuts page, or any of our other social media platforms, Instagram, YouTube, etc. But that's it for another week. Thank you for listening in, and we look forward to your company next time on another edition of the Space Nuts Podcast.
Space Nuts. You've been listening to the Space Nuts Podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.